All right, welcome. Today we're going to dive into one of the most fundamental ideas in all of programming, loops. Think of them as the secret sauce that lets you automate boring, repetitive tasks and turn simple commands into really powerful programs.
You know that feeling, right? Whether it's in real life or in coding, you sometimes have to do the same exact thing again and again and again. In programming, a classic example might be just making a program do something simple, like, say, making a cat meow.
So if we wanted our program to meow 3 times, what's the most obvious way to do it? Well, you could just write the print command 3 times. And you know what? For 3 times, that's totally fine. It's simple, it's clear, it works. But what if we need to think bigger?
Yeah, what if it's not 3 meows, but 500? Are you really going to sit there and copy and paste that line 500 times? I mean, you could, but it would be super tedious, and it would make your code an absolute nightmare to read and manage. This is what we'd call poorly designed code. It's a trap, because imagine you finish your 500 lines of meow, and then someone says, actually, could you make it woof instead? You'd have to go back and manually change every single one of those 500 lines. That's just asking for mistakes.
And this quote just hits the nail on the head. We're programmers. Our whole job is to be lazy in a smart way, to automate the boring stuff. So let's find that better way.
Okay, so meet your first real tool for automation, the while loop. The way it works is actually pretty simple. It just keeps asking a question, and as long as the answer to that question is yes or true, it will keep running a block of code over and over.
So here's how we solve our meow problem. First, we create a little counter variable I and set it to 0. Then the loop asks the question, is I less than 3? The first time, 0 is less than 3, so yup, it prints meow. And then, this part is super important, it adds 1 to I. Without that last line, I would stay 0 forever, and we'd be trapped in a dreaded infinite loop.
So that's the whole cycle right there. You set up a counter, you check the condition, you run the code, you update the counter, and you just repeat that whole process until the condition isn't true anymore. And then the loop just stops itself. All automatic.
Now, while loops are fantastic. They're like the Swiss Army knife of loops. But for those times when you know exactly how many times you want to repeat something, there's an even cleaner, more elegant tool for the job, and that's the for loop.
Just take a look at the difference. See how the for loop takes all that setup, the counter, the condition, the incrementing, and packs it all into one clean, readable line? We don't have to manage the counter variable I ourselves anymore. Python just handles it all for us. It's so much tidier.
The secret ingredient that makes this so clean is the range function. It's a little bit of Python magic. When you say range of 3, you're not just getting the number 3, you're actually getting a sequence of numbers. 0, then 1, then 2. The for loop just automatically works its way through each number in that sequence.
So, looping a set number of times is useful, for sure. But where loops really start to show their power is when you start using them to go through collections of actual data, like, say, a list of items.
In Python, a list is pretty much what it sounds like. It's just a single variable that holds a collection of items. So here, we have a list called students, and it's holding 3 names for us. And this is where for loops just feel so natural. Look at that syntax. It almost reads like plain English, doesn't it? For each student in my list of students, go ahead and print that student's name. Python takes care of grabbing each name one by one. No counters, no range, just pure, clean iteration.
Lists are great, but what if you need to connect pieces of information together? For instance, what if we don't just want a list of students, but we also want to know which Hogwarts house each student belongs to? A simple list can't really do that. For that, we need something called a dictionary.
At its heart, a dictionary is just a way of storing pairs of things. You have a unique key, like the student's name, that maps directly to a value, like their house. It creates a direct link between 2 pieces of data.
And this is what it looks like in Python code. We use curly braces instead of square brackets. And for each pair, you have the key, then a colon, and then the value. This structure is super useful because it lets us look up a value instantly just by knowing its key.
Now, when we loop over a dictionary like this, something interesting happens. The loop variable, student in this case, gets assigned each key from the dictionary. So on the first pass, student is Hermione. We can then use that key to look up its value by writing student's student, which gives us Gryffindor.
Okay, let's take this up a notch. We've been looping in one dimension, kind of like walking down a straight line. But what if we want to build something in 2 dimensions, like a grid of bricks you might see in a classic video game? To do that, we need to put a loop inside of another loop. We call this nesting.
So to build a square, we have to think in terms of rows and columns. We can start with an outer loop that's responsible for the rows. This loop will run 3 times, once for each row we want to make.
And here's the trick. For every single time that outer loop runs, the inner loop runs to completion. So for the first row, the inner loop runs 3 times, printing 3 bricks. Then that little print at the end bumps us down to the next line. Then the outer loop runs again for row 2, and the whole process repeats.
And there it is. That's the result. With just a handful of lines and a nested loop, we've created a 2-dimensional pattern. We've literally built a structure out of code.
And honestly, this is a huge step. By combining the things we already knew, like variables and functions, with loops, we have a really powerful toolkit. These aren't just for silly examples. These are the absolute fundamentals you need to solve really complex and interesting challenges. So with this new ability to repeat, to iterate over data, and even to build complex structures, you've got a real superpower in your programming arsenal. Whether you want to analyze data, build a game, or make some art, loops are going to be at the heart of it. So the only question left is, what will you build first?